Okay, this question's from Cambridge and it comes up every single year as a problem. Okay, so what we want to do is we are considering this function log e to x, and we want to get the inverse function and then find the exact value of the area between log e4, find the exact value of 2, 1 f of x dx. All right, so I'm going to start with c actually, okay? And what this is basically saying is it wants to integrate f of x to calculate the area between 2.5. So there's 2 and there is a half, I presume. So basically what it wants is this area here. Okay, so let's try it out. So what we're going to do is integrate 2.5 and f of x is log e to x dx. All right, now there's a bit of a problem. Now, the major problem with this is that we don't know how to integrate logs in methods. So what are we going to do? Now, these Part A and Part B questions are guides as to what you may consider doing as part of the process. Okay. Now, the technique I'm going to show you is different from what you're expected to do from these two parts here, but is pretty much the same thing. So I'm going to encourage you to kind of ignore Part A and Part B of this and what it's telling you to do, and go about the process the way I'm recommending. Okay, so what are we going to do? Well, I'm going to consider the function, so it's y equals log e to x. All right, now what we're going to do is switch this into exponential form. So I'm going to say that that is e to the y equals 2x. All right, then what I'm going to do is say that x is equal to e to the y on 2. Now what have I done here? I've basically changed the form, okay? Now what does this allow us to do? Well, if you can understand what I'm about to do, let's just consider that. Okay, so if I integrate e to the y on 2 dy, what I'm actually doing is integrating on the y-axis. It's the same function, but I'm integrating for y instead of on the x-axis. So if I did this, here's an idea. What I'm going to do is, instead of finding this area here, I'm going to integrate on y and find this area here. Okay. Then once I've got that, the process is going to be to imagine this as one big rectangle here and subtract this area, the area that I've just found, from the big rectangle. And what it will actually leave us with is this part here. All right, so their way or their method of doing it, they're leading you through a different method, which I think is a little bit tougher, okay? And I think they only do it because in methods, I think we don't integrate on y. I think that that's not part of the course, but I think it's easier to think about the problem if you integrate on y. I don't think it's a big step to get there. All right, so what we need to do when we integrate on y is basically look at what the terminals are going to be. Now, this lower terminal is going to be to here because remember, we want this area here and all of this stuff here. So the lower terminal is going to be 0. What's this upper terminal going to be? So it's like 1.4 or something like that. Well, why don't we find out exactly what it is, because it's going to be the y value when I bang 2 in. Okay, so if I do f of 2, I'm going to get log e4. So the coordinates here are 2 log e4. Okay, so that's actually the y value there. This y value here is log e4. I presume log e4. Let's try it on the calculator. ln 4 is going to be roughly 1.4. 1.4. Okay, so our top terminal is going to be log e4. All right, so let's get started on it. Now, the integration couldn't be any easier. Okay, so we've got to, I've written that down incorrectly. That should be e to the y on 2. All right, so we're going to say that that is equal to, now e to the y on 2, when I integrate is just e to the y on 2. And I want to do that between log e4 and 0. Okay, so let's bang log e4 in. So wherever I see a y, I'm going to insert that. So that's going to be e to the log e4 all over 2. take away e to the 0, which is 1. That's going to be a half. Okay, now e log e4 is just the same as 4 on 2. Take away 1 on 2, which is just 2 take away a half, which is equal to 3 on 2. Okay, so what this is suggesting is that this area here that I've just found, this part here, is equal to 3 on 2 units squared. All right, now that's not what I want. Okay, so what I'm going to now do is get this full area here. Okay, now the full area of this rectangle here is going to be, so I'm going to say area rectangle is going to be 2 units long, and how high is it? It's going to be log E4 units high. All right, so that's equal to 2 log E4 in total. Okay, so what we're going to do now is we know that the full rectangle is that. We know that this part here represents this, so we're going to say area of rectangle take away area of this. So we're going to say, so total area equals all of it, which is 2 log E4 take away 3 on 2 units squared. Okay, let's try it out and see whether we were right or not. So I'm going to use the integral, and this one here is going to be 2. This one here is a half. By the way, the calculator will integrate on logs, so you can get the calc to do it. It's just that we can't do it by hand. ln, what was the function? ln 2x dx. Okay, so we look close, and what the calc's done is reduce this down here, so let's do that step as well. So they've rewritten it as 2 log E2 squared, take away 3 on 2, and then they've grabbed that 2, banged it at the front, and gone 4 log E2, take 3 on 2 units squared. Okay, so that's how we can integrate a log, is by considering integrating the different form of the log and grabbing the area bound by the y-axis, x-axis, and the curve. All right. So not an easy problem. That I remember that problem's been around for a long time. So I remember doing that first, thinking, "Wow, that's really tricky." Okay, so over the years I've done this problem many times. Doesn't look too bad to me now, but I understand when students say, "Wow, that is difficult." Yep, it is. Okay, let's try it out on another problem. So what we want to do is integrate this. So what's it telling us to do? It's basically saying find the signed area between 4 and 0. There's 4 there, there's 0 there. And the function, I presume, f of x equals log e x plus 5. It's got to be. All right, so basically it wants this area here. All right, so what I'm going to do is use the exact same strategy this time. Okay, now let's consider the area of the rectangle first. Let's get that first of all. Area rectangle equals, it's going to be 4 by whatever this value, this y value here is, which is going to be f of 4, and that's going to be log E9. So the total area is 4 log E9. Now we're going to do what the calculator might do on that. See that 9 there? It's going to reduce it. So it's going to go 4 log E3 squared, and then grab that 2 and stick it out the front, equals 8 log E3. All right. Now what we're going to do is the same move as before. So what I'm going to do is, basically at the moment I've got this whole area here. That's what I've got. Okay, so what I want to do is find out this area here. I'm just doing it in a different color so it emphasizes it. All right, I'm going to get this part here. And when I remove this part here from this, from that, what I'm going to be left with is that. All right, so let's get cracking on that. All right, so I'm going to write the function as y equals log E x plus 5. And what I'm going to do is just change the form. I'm not going to write it. I'm not inversing it. What I'm going to do is just write it in exponential form. That's e to the y equals x plus 5. X is equal to e to the y, take 5. Okay, and now what I'm going to do is I can integrate on the y-axis now. So x is the subject, so I can integrate on y. So I'm going to integrate e to the y, take 5, dy. What am I going to integrate between? Well, I know that this top terminal here is log e, what was it? Log e 9. So when I put 4 in, I get log e 9 out. And when I put 0 in, that's going to be log e5. Okay, all right, this is all set to go. So let's do it. So the integral couldn't be any easier. It's e to the y, take 5. Now remember y, I love putting x's there, but we've got to remember to put a y in. And it's log e 9 log e5. Okay, let's whack them in. Okay, so we're going to go e to the y, so that's e to the log e 9, take away 5 log e 9. All right, so that's that taken care of. Take away e log e5, take away 5 log e5. All right, let's see what happens. That is 9. That there, let's reduce and rewrite. I'm going to rewrite that as 10 log e3. So I've done that move where I've written that as 3 squared, grabbed that 2 and stuck it onto the negative 5. Right, that's that part there. That is going to be 5. Take away 5 log e5. Not much we can do with that one. Okay, now let's rewrite it by getting rid of the negatives. So I'm going to go 9, take 10 log e3, take away 5 plus 5 log e5. Now that's 9 take 5, that's 4, take 10 log e3 plus 5 log e5. Let's see if I did that right. 4. Yep, looks good. Okay, so what does that represent? So that's a measurement, that's units squared. That's that area there. Okay, so what I'm going to do now is grab this area of rectangle over here and remove the area of the part I integrated on y. So I'm going to say that this is, what was it, 8 log e3 let's just check that, 8 log e3 take away 4, take 10 log e3 plus 5 log e5. Okay, equals 8 log e3, take 4 plus 10 log e3, take 5 log e5. Okay, now I've got 8 log e3 and 10 lots of log e3. I've got 18 log e3s, take 5 log e5, take 4 units squared. All right, so let's check out how I went there. Hopefully I did all right. Well, if I didn't go all right, I'll do another video, so this better be right. Okay, so the original integral was 4 and 0. The function was ln x plus 5 dx. All right, come on, calculator. 18 log e3, take 5 log e5, take 4. Got it. All right, so there's the questions. 11I, do all of them.